Good afternoon, everyone. I don't need to tell you it's been rather busy the last couple of Julys. So we're going to just go right to it. Look at some of the comparison of what created the July 23rd event, what created July 24th flooding. Also look at finding and interpreting hydrographs, which is still in its infancy because we got some new tools coming our way. And then look at climate change and future impacts, since a lot of this recent flooding has been a result of climate change. So we all remember the July 9th and 11th flooding of 2023. Basically, we had a winter storm in the middle of summer, which is never good when you end up having direct comparisons and contrasts between winter weather and summer weather. It's in a bad shape. And what I mean by that, in a normal, I'll use the pointer here, in a normal winter or late fall situation, you get these upper level lows that kind of drop down. They're very cold. They cause for areas of low pressure to develop. And in this case, where what we consider as negative tilt being from northwest to southeast, it allows for a lot of tropical moisture to come in when it's during the summertime. And again, this is customary what we see in the cool season from October to April. So you have the area of low pressure, it's all stalled. And what you see is a conveyor belt of precipitation. This is an hourly loop, a 48-hour loop. It was a statewide event. The main event was the first 24 to 36 hours, where rainfall rates were in excess of an inch per hour at times. And then largely after that was about a quarter and a half inch. And as we all know, flash flooding ended up transitioning to major river flooding. The rainfall, basically you can see right along the spine of the mountains. Now, in most cases, like with Irene, when Irene tracked across the Connecticut River Valley and we had a pretty good easterly wind, the heaviest rain was on the windward side of the mountains, so the eastern part of the spines. In this situation on July of 23, we pretty much had the boundary right over the spine of the mountain. So both sides of the mountains equally got upslope, and that's why it rained on both sides of the mountain. So it was pretty much a statewide event, widespread 46 inches in the heaviest areas, up to 8 inches in some locations. And then in the Champlain and Connecticut River valleys, it was largely 2 to 4. We've all seen the photographs and the incredible work that our search and rescue teams, our swiftwater teams did during that event. I believe it was 200 rescues, Director. Was that the case, I think, for 23? 250. So quite a job. And remember, last year was not just July 9th and 11th, it was July 7th that started things. And then it went all the way into early August. So everybody was busy. Looking at the Winooski Basin, what it looked like after the flash flooding transitioned into river flooding, we reached a peak of 23.28 feet. That is below the historical mark of 1927. Below a winter snowmelt event of 36, but you can see it was actually higher by about a foot than Irene. And another date you're going to see, because what happened in July 23 was pretty similar to what happened in late June and July of 1973. So at Montpelier, again, it was the third highest. At Waterbury, the gauge hasn't been there that very long, so it was the second highest on record, with Irene being the number one. And then my apologies. The left here is where Montpelier. So Montpelier here was number 2. This one is Essex Junction right here, and it was number 3. So you can see we were either 2 or 3 for July of last year. Go to a couple other basins. Otter Creek, we were number 2. Number 2 at Memorial at Johnson. And then for the White River, we were number 6. Well below the 27 or Irene for the White River, but the tributaries, especially the Oswegatchie and stuff, really got clobbered. Ask Kevin about Woodstock and that area. It really got clobbered last July. So the difference with this year, we had flooding, but the footprint was much shallower, and also the source of it. The earliest Category 5 hurricane before it reached the Lesser Antilles, developed in early July, traversed the lower Caribbean, crossed the Yucatan Peninsula, and then redeveloped again as a hurricane just before it made landfall south of Galveston. And then where these white boxes are is what we call post-tropical cyclone. It's taken over similarities of what a mid-latitude or a winter storm would be like. So that tracked basically up into the eastern Great Lakes and eventually our area. You can see from the radar on the right, you can see how that precipitation with the hurricane first on Monday traveled slowly along and then brought the rainfalls up into our area. Making it a little bit closer to see, here is the post-tropical cyclone Burrow. We had a warm front in another area of, it was a basically elongated area of low pressure, warm front that was moving across the area. This is what we call precipitable water, how much water is in, how much water vapor is in the atmosphere. And you can see where Burrow is associated, it was about 1.8 inches, but leading up to prior to Burrow, 2.2 inches across the area. We had a big Bermuda high sitting off the East Coast and was just setting up the floodgates from the tropical Atlantic. It would be nice, Emily, if I had set that count clock down, so you may have to give me some heads up. So on radar, this area that's oval and black is to show where the main flooding is, and you can see, and these are 30-minute loops, 1-hour loops, so you can see the training of these showers and thunderstorms. When they were across New York, you see these big reds or whatever, these were what we call supercells, and there were over 40 to 50 tornado warnings that were issued for New York State. They never gave us that spin to give us a tornado in Vermont, but nonetheless, when it first moved into Essex County, New York here, we got a report of 3 inches of rain in about 70 minutes. And then it moved up into some of the areas that were hit in late June. And then mainly along the Route 2 corridor, which of course Mike knows for Plainfield and up into St. Johnsbury, with rainfall rates largely up to 2 inches per hour. So the rainfall footprint with this, largely from eastern Essex County, southern Chittenden, northern Addison, the Route 2 corridor of Washington up into Caledonia. If anybody remembers the flash flooding from May of 2011, pretty much that same footprint, identical, that Route 2 corridor. And you can see some of the rainfall reports and amounts I broke up by county. So you see some pretty good totals in there. Some of the pictures. This one, I was at the Champlain Valley Fair and I had a static display of the flooding. Lady comes up to my booth going, "Hey, that's my picture." And she showed me on her phone. Sure enough, it was. I said, "You mind if I use it?" She's like, "No." And then she told me the story. Once they got this thing out, it served in recovery efforts over there. So John Deere could definitely do a commercial about how rugged a John Deere is after getting swept away like that. And it was helping in recovery efforts as soon as they got that recovered. So I thought that was a pretty neat little story. So the main stem flooding was not as great. The footprint wasn't as great, except for some communities. Mad River did get up to, you see down here, it was down around number 8 on their list or whatever, but they did surpass what happened in July 2023. This would be the Mad right here, because they really weren't impacted by July 23, or not as much. And then the Subsic, which wasn't affected too much on the 2023 event, really got impacted, and it's their third highest historical record, just below that of 1973, as we have mentioned before. And also you can see on the Mad River, December 23, that was due to snowmelt, and the snowmelt we had in December. So some significant flooding in some places, other places not so much. In terms of the Winooski Basin, which I spent a lot of time on earlier, at Montpelier, it never did flood. Despite upstream Plainfield and all that, the reason why it didn't flood is the basin upstream from pretty much East Montpelier to St. Johnsbury saw similar rainfalls that they might have seen just last summer, or from the flash flooding event of May 2011, but up around the Wrightsville Dam area and the tributaries of the Dog River, those rainfall amounts were less than 2 inches. And just not getting only 80% contribution into Montpelier, or not getting the full 100%, just kept them below flood stage. It was rising rapidly, as you can see, but it kept them below. But downstream at Waterbury, because you also have the contributions coming in from the MAD, which I don't show here, it got up to major flood. And again, it's a shorter duration, but it's the third highest on record. And then Essex Junction, it ended up being the sixth highest on record, just about almost 3 feet below what they experienced in the July 23 flooding. And then the other one that was Main Stem River that reached major flood was the Lamoille River at Johnson. You can see that it ended up being the fourth highest on record. July 23 was the second, and then you can see 1973 comes in here, and Irene comes in down at number 9.
As a point of information, really quickly, when does that number indicate when you say 27 feet, 1927? What is 27 feet referring to?
It's taking a watermark that's the USGS gauges in the river, and it's taking from where they observed or surveyed where the flooding was, and then they transpose it to what is that level above that watermark.
Okay.
So less than a month later was Debbie, and you can see from the radar shot in here, we did get some rains with Debbie, but the main rain was associated, this is Debbie tracking up here, was right on that left quadrant, that northwest quadrant of the storm. But the storm thankfully moved west of the Champlain Valley. So we absolutely dodged a bullet, because if you took this with a storm track right across the Adirondacks and placed it where the forecast was 2 days before the event in the Connecticut Valley, that would have been right over what we experienced in July. So we really dodged a bullet on that one. Although we did have power outages, more than 50,000 outages due to the winds with Debbie. So hydrographs. I don't see a countdown on there, Emily. It went off. So if you live along a river that has a forecast point, or an observation point, you want to go to the National Weather Service Burlington website. Either click up here for rivers and lakes, or this icon here for rivers and lakes, and it will get you to this new display called the National Weather Predictions System. Anything that is a box is an official forecast point where they'll collect rainfall data, add future rainfall data, put it in computer models, and the Northeast River Forecast Center will make a forecast up to 72 hours for anything that's in the squared box. Anything that's a circle is strictly observational data and no forecast. So that's the new display of that page. If you bring it down to the homegrown, I'm looking here at Montpelier. I'm taking the actual forecast point one. So if you look at the graph here, display looks different than the one I've shown you earlier, because they've changed how the background of it, but it still gives the same data. This is all the observed, and then this is the forecast point. You can also get flood impacts based on surveys and previous floods. A certain river level, we will give you what we expect for flooding based on previous flood events, as well as recent and historical crests. So all that is available on there. And like I said, here's the format now, here on the left, and here was the previous format. But there is a way of getting it like this. You prefer this breakout easier, and that is, if you click on this tab here, it will say there's one thing that says static hydrograph or static display. You click on that, and it's going to give you that version. So just for your knowledge. There is what we call an ensemble river forecast, which runs once a day. It's on for all these sites you have here with only 2 computer models. But within those models, there's at least 20 different simulations that are run. It's hard to see here, but the simulations would be how much rainfall they put in the computer model, and then the results of the rainfall in that computer model. Anything in the blue is taking the middle 50 percentile of what's expected to 25 to 75 percentile. You can barely see it up here, but the green would be up to 90%, and then the tan or whatever is the 95 percentile. So they only color code for precipitation to blue, so trying to interpret what may be the 90% versus what may be the 99% or the 1% chance, that is difficult. And again, because it's used with caution, because there's multiple simulations, there's multiple solutions. The ranges of possible solutions are crazy, to say the least. There's really no QC being done right now. And again, a limited runtime of only once a day. It's run from the Northeast River Forecast Center. We are working with them. We are working with them to try to get these color coded. So that way, what happened with the July in Burl was we had forecast widespread 2.5 to 3.5 inches of rain, but we knew there was going to be a swath of 4 to 6. So in order, the River Forecast Center for their forecasts, when they made forecasts out here, ended up going basically 2.5 to 3.5 inches basin wide. But we knew once we found a swath that was going to be 4 or 6, that those amounts would be higher than what was forecast. The only problem was the data, even in this graph here, did not go as high as the rainfall did. What we're hoping to do and working with the River Forecast Center, and I did some of it today, setting up a spreadsheet, is maybe 2 days out, say, can you run a contingency run for 5 inches basin wide? Run it for the whole state. It won't be available to the public. It would be available to us, and it won't be even available in a graph form like this. They're just going to give us numbers, but we run it for the whole state at a higher level. But the real-time stuff that you see on our webpage would be for the lower 2.5 to 3. But then that way, once we find that basin that gets hit with the 5 inches, I've got some sort of, or anybody's got a reference point of what it very well could be. So it gives some decision makers, whether it's Swiftwater or local towns, it gives them a mark of what to do. Because I know with the Borough situation, when they were in the middle of it and then they hyped it up, Montpelier went from, I think it was 12 feet, and their flood station's 15, all the way up to 17 feet. And that, you can only imagine, set alarm bells all over the place. Okay, and finally, I'm going to talk a little bit about climate change and the wetter climate. Basically, we all know climate is changing. In the Champlain Valley alone, since 1970, the average annual temperature has risen close to 5 degrees Fahrenheit. In the summer and spring, it's been 3.5 degrees. In the fall, nearly 5. In the winter, 8 degrees above where it was in 1970. For every 1 degree Fahrenheit that the temperature rises, it equates to about 4% increase in what the atmosphere can hold for water. And this is especially true for the Northeast. This is a study that shows that for the heaviest 1% rainfall events, so you take all your rainfall events, your highest 1% rainfall events, in the Great Lakes area, there's been a 40% increase. In the Northeast, there's been a 71% increase. If you, I'll get this before today is over. If you look at the lower scenario for emissions, then we're looking at the next, by the end of this century, we're looking at an increase at about 30%, but the higher scenario is greater than 40% increase. So needless to say, we're in for a 30 to 40% increase in more heavy rainfall events. Another tab to kind of show this, the days with 2 inches of rainfall have increased by 50%, 60% for 3, 84% for 4 inches, and over 100% for 5-inch rainfall events. Yet, the annual rainfall has only increased 21%. I say only, but when you're referencing it to these values, that's pretty significant. So what does that tell us? We are seeing more heavy rainfall events, but the periods of dry weather between these heavy rainfall events. So you're getting heavy rainfall, then you're getting these long periods of what you could almost call a flash drought, depending on when you see it. And what that means is you're going to get periods of drought, but then you're going to see more flash flooding take place. Basically, you're looking at climate variability, and this is an excellent example. July 4th last year, we were in various stages of drought, from abnormally dry to moderate drought. And then a week later, and basically all of last summer. So just to sum up of recent changes and future impacts on a climate and meteorological scale, warmer and wetter is largely what we're going to see with droughts and floods. And what I mean by floods as well is it's not just a flash flood. we're going to see more wintertime spring flooding. I mean, we used to, and VEM, with Emily being in charge of this, we used to try to get those spring flood workshops before the spring flooding. I remember when we first started them, they were like March, April. Then we moved them until late February. Then we moved them to early February. And now we've had, you know, last year, which was one of the gauges, I think it was Mad River, that had the third highest level on record from the December flooding of last December. We're now getting spring flooding in December. So we're going to see more of that. We're going to see more of that. So for agricultural wise, of course, you've got the impacts of drought and flood. Maple industry potentially gets impacted with early warm spells. I mean, technology is allowing them to do sugaring in January, but I don't know, sugaring in January just doesn't seem right with me. Invasive species, apple and grape crops, and maybe other crops that have fruit on their trees. They had a big impact. If you were anything outside of 3 or 4 miles from Lake Champlain, you didn't have an apple or grape crop last year. Mid-April last year, Jason will like this one, I went to see the Habs and the Bruins for their last season, regular season game in April 2023.
In Boston?
At Montreal.
Oh.
And it was in the mid-80s. This was April. And it was 80s all that week. But then come mid-May, which is our normal last freeze into Champlain Valley, mid to late May, we got to 28 degrees. But the apple crops and all the flowerings and the buds and the fruit were already exposed, and you lost everything. We're going to possibly see more of that. Whoops. One benefit, we may have a longer growing season. For recreational, downhill ski and the ski industry, for the most part, will be okay. The big ski areas will make the snow. The technology has allowed for them to make it at warmer temperatures and be more efficient with the water. But smaller places, maybe like Middlebury Bowl, maybe Cock Rings or whatever, they may have a little bit difficulty in doing it. If you do cross country or the snowmobile trails, you're blank out of luck. Lake and pond fishing is going to be difficult. This is February of this year, February 24. And the black is open water, and the white up in here is any frozen ice, which is only basically Missisquoi Bay for mid-late February. We're seeing folks go through thin ice, not this past winter, but the winter before, at least 6 fatalities on Lake Champlain alone. Longer, warmer season means more hiking and biking. Health conditions, heat-related illnesses continue to increase as the number of warm days continue to increase. The number of 90-degree days just 30 years ago, we averaged 6. We're now averaging double at 13. And the number of days that are 85 or greater in this state is anywhere from 3 to 5 times the number of 90-degree days. So that's a big situation there. And what we've seen a lot is this power grid damage thing from wetter snowstorms. We're used to in Vermont, the climatology for snow in Vermont is for every inch of rain, you get anywhere from 13 to 18 inches of snow. We've had 4 or 5 storms in the last 2 winters that have been 7-to-1 ratios, meaning only 7 inches of snow for 1 inch of rain. That weights down on everything. And the power outages have been crazy. In fact, Green Mountain Power shared with me a spreadsheet of their top power outages, and I think 4 of the last 10 have been in the last 2 years. 3 were from the heavy wet snow, and the 4th one was from damaging wind events. And just tell communities, if not officially becoming a storm-ready community, be storm-ready. Make sure you have emergency action plans set, so that way when that storm hits, you've got a binder you can go to, and you can go and make actions and call your emergency officials and call the state or whatever, and not try to do everything by the seat of your pants. So just with the changing climate, there's going to be more of these type of events. And with that,